Hello and welcome to the video on VLSI physical design. So in this video we are discussing about timing driven routing. So the timing driven routing seeks to minimize the maximum sync delay, which is the delay from the source node to any sink in the net, and also minimize the total wire length, which is the total routed length of the net. So we will take it like a weighted graph problem where let S node be the source node. Let there be n sinks denoted by S1 to Sn. So we will draw a weighted graph G for V vertices and E edges. So the vertices V0, V1, Vn will represent the source and the sink nodes of the net, and the weight of an edge between Vi and Vj will represent the routing cost between those two nets Vi and Vj. So the edge will represent the routing cost. So for any spanning tree, let radius be the length of the longest source and sink path, and let cost be the total edge weight. So we will have two parameters, radius and cost. Radius will be the length of the longest source sink path and cost will be the total edge weight. So we will have two type of trees, shallow and light trees. So shallow trees will be having minimum radius. So they will be the shortest path trees, and the light trees will have the minimum cost. The shallow trees are constructed by using DJ-Krista algorithm, and the light trees are constructed by using Prim's algorithm. So we will have the trade-off between shallow and light trees. So if we minimize the radius, the cost will go up, and if we minimize the cost, the radius will go up. So these will be the two type of trees that we will be considering in timing driven routing. So let's take an example. So in this example you can see we are taking 4 nodes. So the longest path is from S0 to the last node, which is of radius 8, and if we count the length of all the paths, then that cost is 20. So this is a shallow tree with minimum radius. Then we also have a light tree with minimum cost, so that the cost of all the paths is 13, but as you can see the radius has increased in this example. So this is a light tree. So if we do a trade-off between these, then we will have another tree, so where the radius is increased and the cost is also increased. So this is the trade-off between the shallow and light tree. So if we increase the radius, the cost will decrease, and if we increase the cost, the radius will decrease, and vice versa. So in these three examples we can understand the difference between the shallow tree, the light tree, and the trade-off. So the three graphs are clearly representing the trade-offs. So in the first and second graph you can see the radius was 8 and the radius was 13, whereas in the trade-off the radius was in between, which is 11. Again in the first and second graph the cost of was 20 and 13, and in the trade-off graph the cost was 16. So in between the shallow tree and the light tree. So this is the trade-off. So please like and share the video and subscribe the channel if you want to see more such videos on VLSI physical design, because I regularly make videos on VLSI, also make videos on Cadence Virtuoso and Xilinx Vivado for VHDL coding and Verilog coding as well. So please like and share the channel and also subscribe the video. So we will have a algorithm which is called as bounded radius and bounded cost algorithm. So it is also called as BRBC algorithm. So in this BRBC algorithm what we have is, if we trade off the radius for cost by setting the upper bounds on both of them. So let TS be the shortest path tree, let TM be the minimum spanning tree. So BRBC is the tree which is constructed with parameter epsilon. So you can see the radius and the cost of BRBC tree are dependent on this parameter epsilon. So if we minimize this epsilon, that is if this epsilon is equal to 0, then the BRBC tree will have the minimum radius, and if this epsilon is infinite, then it will have the minimum cost. So you can see when epsilon is equal to 0, then the radius of BRBC tree is equal to the radius of the shortest path tree, and when epsilon is equal to infinite, then the cost is equal to the cost of the minimum spanning tree. So in this way, and if the epsilon value is between 0 and infinite, then it will be a BRBC tree which will trade off the cost and the radius. So this is the basics introduction to the timing driven routing. So thank you. Please like and share the video and subscribe the channel, and best of luck.